Hello, this is Mr. Mitchell with another physical science video. This time we're going to be talking about some thermal energy transfers with some terms that you have heard before: conduction, convection, and radiation, but I do want to make sure that you know them. Conduction happens when you have direct contact between the thing that is being heated and the thing that was already hot. Now this is usually between two solids, so the key here is direct contact. Here we have the heat source, which is the eye. It is making direct contact with the pan. Heat source has molecules that are moving faster. Pan has molecules that are moving slower, and it is heating the pan. And at some point, the molecules in the bottom of the pan should be moving at the same speed as those from the heat source. Also, you've got someone holding some kind of stick over this candle. Now, the transfer is not between the transfer I'm talking about. It's not between the candle and the stick. It's between the stick and the person. The stick gets warm, and as a consequence, the person's fingers get warm also. So we have heat transfer from the stick to the person, and that is conduction because that is solid on solid, and you'd have direct contact, and that is kind of what conduction is. Now, the difference between conduction and convection is the direct contact. With convection, you have a heat transfer that is through a fluid like air or liquid. So you do not have direct contact, and you have to have a convection current whenever you have convection. And I'll type convection current here. You have to have a convection current, and here you can see off to the side the convection current. You have the heat that is going up from the fiery chair here. It is going up. The heat is going up, and that displaces what the air was already up here, and it kind of curves around, and you can see what the cooler air goes down. You have the hot air transfer that is going up, and that pushes cooler air to going down. And the same thing happens here with this pan. You have this pan that is on the heat source. The hot air goes up, or the hot water or liquid goes up, and it forces the liquid that was already there to kind of curve down to the sides. Now, this is called a convection current. Happens in the mantle of the earth, happens with fires, happens anytime you have convection as a means of heat transfer. So you do not have the direct contact. You have the heating goes through some kind of convection current as it goes through a liquid or the air. So that is convection. Has to have the convective current, and they have to have it's not direct contact. The final one is radiation, and radiation is, well, it's neither of the others. It does not involve touching or a convection current, and it can happen over long distances. Over a short distance here is somebody with their hand that is near the fire. If you're a few feet away from the fire, your hand is not in the convection current that is going up, but you still feel the heat. And if this were a big enough fire, you could feel the heat 100 feet away. But that would be because of radiation. You're not in the convection current. You are far enough away to where you do feel that heat going to it. And the reason I have the sun and the earth here is that's exactly how the earth gets heated. You have the light from the sun, which is going from one direction to another. It's not in convection current. It's not touching each other. It doesn't even have to have air for the heat to go to us. So, good example of radiation is the way we are heated from the sun. So I have a slide which has all three. Okay, so the direct conduction here, if the pan were to be set down, would have conduction. Remember, that's making contact. You have direct contact between the bottom of the pan and it, but you do have direct contact between the handle and the hand. So you have transfer of heat by direct contact here, and it did have direct contact as it was on the eye earlier. You have inside the pan convection because the bottom of the pan is heated and it forces up the hot liquid and it pushes the liquid around. So you have a convection current, that is, I mean, you have heating that is going on because of convection inside the pan. And radiation, you do get heat that is coming out from here that if you were to put your hand a foot away that you would feel it, but it's not inside a convection current and it's not directly touching it. So you do have all three there. And here we mentioned that we have conduction, convection, and radiation on a fire. Conduction would be from the hand to the stick. You have direct contact and you have the heat going from one to the next. Convection, wow, this time the person's hands are in the convection current, so it is actually going through the air and pushing around. But here, when the person's hand is not in the convection current, you have a heat transfer by radiation. A couple of other things about heat. You don't always have to have conduction, convection, or radiation to have heat. For example, this person and this person are creating heat through friction. They are rubbing their hands together, and in rubbing their hands together, they're creating heat. So when objects touch and move, you have that friction when they touch and they move against each other. So that is one way you can create heat, by friction. And if you think about it, everything has some degree of movement. You may remember in a previous lesson we had the pencil on your table is moving even though it doesn't move. It looks like it's moving because at the molecular level all the molecules are vibrating, are moving. So you have heat in almost any object. Now I happen to have here some rules, but I want to point down to this person at the bottom pushing some box. I don't know if you can read this, but this pushing the box here is causing heat due to friction. If you push something across the floor, you have friction coming from the floor. That means you have heat. If you have inside the engines of an automobile, you have pistons moving up and down, creating friction, and you have heat. But let's take a look at these rules. These are called the rules of thermodynamics, but you can just remember them as laws of heating. First one, anytime work is done, there is heat. So think about this. When you have work, you have force and a force throughout a distance. And force throughout a distance is always going to have some kind of friction. So since you have some kind of friction, you have heat. So anytime there is work done, there is heat. And finally, heat travels from a higher concentration to a lower concentration. I'll look at this picture here. Here we have a radiator, which is an old-timey way of getting heat into a room. So it's warm, and here you have a cat whose body temperature is warm also. So you have two things that could potentially warm each other. But in this case, the one that is hotter, most likely the radiator, is going to warm the cat. You will not have the cat warming the radiator because it has less concentration of heat. So anything that has a lower concentration of heat is going to be heated by the thing that has the higher concentration. So heat travels from the radiator to the cat, even though the cat is relatively warm anyway. Hey, I hope you learned a little bit more about heat and its transfer.